In this video, we will learn how to determine the resultant force of three separate forces using the XY component method. The three forces are shown in the diagram. We start by looking at each of the three forces individually and calculate the X and the Y component forces of each of them. Let us look at the first force, which we will label as F1. The X component force will be labeled as F1X and the Y component force will be labeled as F1Y. We can calculate the magnitude of F1X by using the formula F1X equals F1 cosine the angle θ1, where angle θ1 can be calculated from the tangent inverse of 4 divided by 3. Tangent θ1 is equals to 4 divided by 3. Therefore, angle θ1 equals to tangent inverse of 4 over 3 equals to 53.1 degrees. So F1x equals to F1 cosine of the angle θ1 equals to 280 cosine 531 degrees equals to 168 Newton pointing to the right. F1y equals to F1 sine of the angle θ1 equals to 280 sine 53.1 degree equals to 223.912 Newton pointing upward. We now look at the second force. We will call this force F2. We will label the X component force as F2X and the Y component force as F2Y. We need not calculate the angle since it is given as 40 degrees. F2X is equals to F2 cosine 40 degree equals to 160 cosine 40 degree, and that's equals to 122.567 Newton pointing to the right. F2y equals to F2 sine 40 degrees equals to 160 sine 40 degrees equals to 102.846 Newton pointing downwards. We next look at the last force and label it F3. The x component force is labeled as F3x and the y component force as F3y. F3x equals to F3 cosine 25 degree equals to 220 cosine 225 degree and equals to 199.388 Newton pointing to the left. F3y equals to F3 sine 25 degree equals to 220 sine 25 degree and equals to 92.976 Newton pointing downwards. Now that we have calculated all the x and y component forces, we can now sum up all the x component forces arithmetically since they are either pointing to the right or the left directions. Component forces pointing to the right will be assigned a positive sign, while those pointing to the left will be assigned a negative sign. So Rx equals to the sum of all x component forces equals to F1x plus F2x plus F3x. Equals to positive 168 Newton plus positive 122.567 Newton plus negative 199.388 Newton. And equals to 91.179 Newton pointing to the right. Note that since the answer is positive, the direction of the horizontal force is pointing to the right. Similarly, we will calculate the resultant of all y component forces pointing either in the upward positive or downward negative directions. Ry equals to the sum of all y component forces equals to F1y plus F2y plus F3y. Equals to positive 223.917 Newton plus negative 102.846 Newton plus negative 92.876 Newton. Equals to 28.195 Newton pointing upward. Note that since the answer is positive, the direction of the vertical force is pointing upward. We next draw a simple right angle triangle from Rx and Ry to indicate the direction, angle alpha to the horizontal shown, and the magnitude R of the resultant force due to these three forces. From the drawing, the magnitude R is equals to the square root of the sum of Rx squared and Ry squared. Pythagoras theorem. Therefore, R equals to the square root of 91.179 squared plus 28.195 squared. This equals to 95.438 or equals to 95.44 Newton. Tangent alpha equals to Ry over Rx. Hence, angle alpha equals to tangent inverse of 28.195 divided by 91.179 equals to 17.183.